Hello students, today we're going to talk about thermal energy. Go ahead and set up your Cornell notebooks, and this is Cornell notes, so it's going to be an advanced question and a summary. Alright, let's get started. First, a thermometer. So last time we talked about temperature. Well, a thermometer is the tool that is used to find temperature of an object. And it works on the principle of thermal expansion, which we'll get to in a minute. The question on the left you can use is, what is a thermometer? Or how does a thermometer work? So a thermometer has a liquid in it. It used to be mercury. Now they use an alcohol. And what happens is, it works because the liquid, the alcohol, is made of atoms. And as the temperature increases, the atoms move around and spread apart, which means that this liquid can't go anywhere because it's sealed in glass. So since the atoms start moving faster as the temperature increases, they have to go somewhere, so they go up. And that's how a thermometer tells you the reading. If they slow down, then of course it goes down as they contract. And that's the idea of thermal expansion, which we'll get to in a minute with a different picture. All right, ready for number 2? Thermal expansion. Thermal expansion is when an object is heated, it expands and changes in density. Same thing applies when it's cooled, except instead of expanding, it contracts. Let's look at a picture. Let's look at this hot air balloon right here. So of course, a fire or flame is a chemical reaction. And this chemical reaction releases energy, causes the atoms of air to move around and to move faster and faster. As they spread out and move this way and that way, the temperature increases and they start moving more. When something cools down, the atoms get closer and closer together until the atoms usually are close enough to create bonds. Okay, go ahead and come up with your question for 2. And let's move on to 3. Heat energy, which is just one type of many types of energy, usually flows from an area of high energy to an area of low energy. Now I know we're used to this idea of cold, but technically, scientifically speaking, there is no such thing as cold. There's actually just energy flow. What I mean by this is, for example, the atom here, sorry, not the atom, the hand has more energy, and the energy is transferring from the hand into the ice cube, because your hand usually is of higher temperature than the ice cube, so this energy is transferring over. Think of kind of energy transfer such as like a river. In a river, let's say this waterfall here, the water is always going to move from the highest place to the lowest place it can find. So it flows. So energy flows like water and it always goes from a place of high temperature to a place of low temperature. So in this picture, the energy is flowing into the ice cube. This drop in temperature is received by your brain, and your nerves from your hand send that signal to your brain that there's been a drop in temperature, and we interpret it as cold. All right, go ahead and come up with a question for 3. All right, last idea for today. Thermal energy. Thermal energy is the amount of energy in an object, but it depends on the amount of atoms or mass. This one's a little bit tricky, so make sure you're listening so you can understand it. So thermal energy is how much energy is in these atoms. It depends on how many atoms the object has. This picture should hopefully make you understand it a little bit better. For example, if this spoonful of soup and this bowlful of soup are the same temperature, let's say this one's 100 degrees and 100 degrees Celsius, the bottom of the soup has higher thermal energy, more thermal energy, and the spoon has less thermal energy. And you know this because if you take a spoonful of soup, it's going to cool off faster than the bowl of soup. For example, when we are eating hot food, we use our spoon, and then in a couple seconds it cools off. They were the same temperature, but then this one cools off faster because it has less atoms, so it loses more energy because it has different amount of atoms. So again, with thermal energy, it's dependent on how many atoms something has, or the mass, and how the atoms are moving in that object. Okay, come up with your question for 4 and then move on to your summary and your advanced question. Have a good day.